Good morning, everybody. Welcome to a sunny Monday morning of Chem 1211 with your host, me, Dr. White. All right, lots to do. All right, game plan today. I have some announcements to make. Let me get this off my screen. Announcements to make. Then we'll go through quiz 3 answers. Then I'll do the review for quiz 4 and I'll do the problem set for solutions. And if we have any more time, we'll get back to equal our chemical rates and other things that will be on quiz 5. All right. First announcement, let's get to Blackboard. All right, everybody see announcements on the screen. Thank you. All right. First of all, tomorrow is election day here in the United States. And in Illinois, it's been made a holiday, which means COD will be closed. Therefore, I will not have any meeting tomorrow, class or lab, and I will not have my office hour. Don't forget, vote. If you haven't voted, you should. Brave men and women have died so we can vote. By the way, I voted last week by early voting. Actually, I mailed it in. All right, next important information, quiz number 4. On Saturday, I posted, you should have got this email, on this Wednesday, the 9th, at 11 a.m. or a little before, at that time, I'll be emailing you the password for quiz 4 PDF file. You'll have until Thursday morning, the 10th, at 11 a.m. to take quiz 4 and upload your answers as a single PDF file. You've done that before with quizzes 1, 2, and 3 and your labs. I reserve the right to subtract up to 25 points from your quiz 4 point total. If you don't follow instructions, meeting should be a single PDF file, and if you don't upload it on time. Now, quiz 4 has 5 pages, 13 problems, including 5 multiple choice questions. It's worth 50 points plus it's got five bonus points. It'll cover chapter 12 and part of chapter 13 in our book dealing with solutions. And a little later after this, I'll do the review after I go through quiz 3 answers. I'd highly recommend that you download quiz PDF file, quiz 4, and your periodic table PDF file the day before I give that quiz. That means tomorrow, I think I have it set up by 9 a.m. or 10 a.m. You will be able to download all this. You won't be able to take it because you don't have the password. I'll be posting quiz 4 scores by next Sunday, 1 p.m. or earlier on Blackboard. At that time, I'll post an announcement and send you. You'll also get an email that quiz 4 scores are in Blackboard. I'll also, like I did for quiz 1, 2, test 1, and quiz 3, I'll email into each individual student the points you receive for each answer. A week from today, I will go through the answers for quiz number 4 in our Zoom meeting, but I'll cut it out, delete it from the, I like my special effects. I got that down pat. But anyways, I'll go through the answers next Monday. If you can't come to Monday's lecture, you can always come to my office hours, or if you can't come to my office hours either, let me know. And if I'm available at the time when you're available, I will set up a private Zoom meeting to go through those answers. All right, so again, tomorrow, no class or lab. We'll do the lab that we would have done tomorrow. I'll go through. I'll do that on Wednesday. Good news, we're on track. So yes, I'm going to lose some time tomorrow and you have to make it up on Wednesday, but doesn't put us behind. All right, any questions on quiz 4? If you can do the practice problems correctly, you'll do well on quiz 4. All right. With that, and that's test of that. I keep on wanting doing like I've done all these years. I never give quizzes except this is the first semester I had to. Uh, that's quiz number 3. 3. All right. Now, if you're looking at what did I do on that? If you multiply what you got by 2, your quiz 3 score. If it's 90 or above, you got an A on the quiz. If it's 80, 89, B, 70, 79, C, 60, 69, D, and below 59, lower F. And that's how you can evaluate it. I didn't have time, but I'll have to for Wednesday, based on quizzes and tests you've done so far. How do you determine what your grade in this class is? I'll do that for Wednesday. Any questions on quiz 3? In that case, let me close it. All right, everybody see on your screen, quiz 4 review. Thank you. All right, this Wednesday after class online, you'll have until Thursday, 11 a.m. to hand in your answers for quiz 4. Quiz 4 deals with the chapters 12 and 13 on solutions. All right, first of all, you should know a solution. It contains a solvent, and that's the component present in the greatest amount, and all other components are called solutes. And after I'm done with this review, we'll go through the chapter solutions problem set. Now, something you might be fooled in thinking it's a solution, but it's not, is a colloidal dispersion. And a colloidal dispersion are particles suspended in another liquid or a liquid. And how can you tell it? It's not a solution and it scatters light. Oh, look out. It's time for me to show off one of my cool flashlights. Those are auxiliary. Let me lower the brightness. Oh, look, if this were a solution, the light goes through. If this were a colloidal dispersion, the light doesn't go through. And this is my custom-made flashlight that I got from a gentleman in China who custom makes the best flashlights in the world, Hank Wang. And you go to our flashlight, you'll learn about that. All right. And examples of colloidal dispersions you should know are mayonnaise, latex paint, and your blood. Just in time for after Halloween. By the way, don't try taking any blood and shining a light through it. Please don't. All right, next thing that you should know that's very important is the concept. It's called the rule of thumb because it's almost always true, but not always true, which would be a law, is like dissolves like. And that means like solutes are soluble in like solvents. And what it really means is polar solutes are soluble in polar solvents. Nonpolar solutes are soluble in nonpolar solvents. Example, water, alcohols, and salts are polar. Vegetable oil, gasoline, Vaseline, baby oil, grease, and dirt are nonpolar. And notice it says, and know this. Well, it doesn't say and, I just added it. Now, next I talked about the solubility of a solute, and that's the maximum amount of solute that will dissolve in a given amount of solvent. And when you reach the solubility limit, if you try and put one more molecule, this one little bit, it's not going to dissolve and it'll precipitate to the bottom. You know what precipitate means. Now, definitions you should know. Types of solutions. The first one, saturated solution. That contains the maximum amount of solute that can be dissolved under the conditions the solution exists. Essentially, you've hit the solubility limit of that. And again, like I said before, in a saturated solution, you try and put one little bit more, it won't dissolve because you've reached the limit of what you could, and it goes to the bottom as a precipitate. Now, a dilute solution is the opposite. That's the solution that contains a small amount relative to the amount you could dissolve. And then there's a concentrated solution. It's got a large amount of solute, but it's not saturated solution. And this has a large amount of solute relative to the amount you could dissolve. Now, when we talk about solutions, a very important concept, a type of solution is aqueous solution. And that's a solution in which water is the solvent. Again, an aqueous solution is a solution where water is the solvent, and it's abbreviated by, not the period, hold on. By bracket AQ close bracket. Whenever you see that, that tells you the solution is aqueous and the solvent is water. Now, next, when I talked about concentration, and I talked about percent concentration by weight, by volume. That's not going to be on quiz 4 or my final. But then the most important to chemists, at least to me personally, is molarity. And molarity, which is shown by a capital M of a solution, is the ratio giving the number of moles per liter of solution. So whenever you see molarity, that's moles of solute per 1 liter solution. However, 1 liter equals 1,000 milliliters of solution. And therefore, I could also say the molarity, and this is the one chemists use in a lab, and that's moles of solute per 1,000 milliliters. Oh, look, it says, very important, know this. And in order to make up a molar solution, there's a 2-step problem or activity you do when you're trying to find, I'm going to go through a problem in the problem set. How many grams of a solute do you need to make so many milliliters of a known molar solution? And that requires 2 steps. The first step what you're given in milliliters, you convert to moles. And I'll do this in a little while, either before or after today's break. Second step, you have to convert now the moles to grams, just like in quiz 3 and test 1. And in case you forgot, 1 mole of an element equals the atomic weight of that element in grams. 1 mole of a compound equals the molecular weight of that compound in grams. The molecular weight of that compound is the sum of all atomic weights. And that's quiz 4 review, which is this Wednesday. Any questions on quiz 4 review? All right, let me close that. Let me open up something I haven't opened up. Actually, I don't have it on this machine. All right, everybody say quiz 4, important information. You will be given this on the last page of quiz 4. And notice a lot of the definitions you're not given. Those you're going to have to memorize. I got to put some things in here you have to memorize, and I'll do that this quiz. But this will be given to you on quiz 4. Wow, we're doing pretty good time-wise. All right. With that, let's start chapters 12 and 13, meaning solutions, practice problem. Everybody see it on your screen. Thumbs up, people. Thank you. All right. These are, if you know how to do these, you'll do good on quiz 4. Shh. If you know how to do these, you'll do real good on quiz 4. Hint, hint, wink, wink, say no more. That comes from Monty Python. How many people know about Monty Python TV show and their movies? Give me a thumbs up if you know about Monty Python Flying Circus. Boy, time out for personal education time from Dr. White. Boy, this is an oy vey time. If you don't know about Monty Python Flying Circus back in the, I hate to say this, the late 70s, early 80s, it was on Channel 11. It was from England, and it's probably one of the funniest comedy shows ever. It's amazing. And you can find some of their skits on YouTube. And they have some great movies. Monty Python, the Holy Grail is a great movie. but these are some of the fun skits from their TV show. Hell's Grannies is good. The Funniest Joke in the World is a really good skit. And anyways, back to work. All right, let's go through some questions. Give an example of colloidal dispersion used in your daily life. And examples of that would be latex paint, milk, or blood. Give an example of a solution that you use in your daily life. There's a lot of them. Tea, pop, remember Dr. White's from the Chicagoland area. And we don't call the stuff in cans or bottles that's carbonated non-alcoholic soda. I had to think for it for a while. We call it pop. I tell you, I love Dr. Pepper and I love Werner's. If you go to Jewel, look up Werner's. Now, if you just put sugar and water together, that's a solution. Water alone is not a solution. And the air you're drinking, the air you're breathing is a solution. Now, number 3, if a solution has 12 grams of KBr and 10 grams of water, what's the solvent and the solute of this solution? The solvent component present in the greatest amount, and that would be KBr. And the other thing, water, is the solute. Now, normally you think of water as a solvent, but it doesn't have to be, like in this case. And I have a few other cases, and here we have ethanol and water, 56 grams of ethanol, 125 of water. What's the solvent? Water, it's in the greatest amount, and the other component, ethanol, is a solute. All right. Number 6, what does 134 capital M mean? As soon as you see the capital M, molarity is moles of solute per 1,000 milliliters solution. So as soon as I see that capital M, I know the number in front is how many moles, 1.34 moles. What's the solute, hydrochloric acid, HCl, per 1,000 milliliters. Now in number 7, I ask the same thing, plus another question, and that is, what does 4.56 times 10 to the third capital M NaCl bracket AQ close bracket means, and what is the solvent of the solution? Well, as soon as you see capital M, you know that's moles of solute per 1,000 milliliters. And therefore, the number in front of the capital M is how much moles, and the formula after the capital M, sodium chloride, the molecule that's the solute per 1,000 milliliters solution. And this bracket AQ close bracket, that tells you the solvent is water. Again, bracket AQ close bracket, the solvent is water. All right. How many moles sodium chloride are in 125 milliliters of a 3.45 capital M NaCl solution? As we've done all semester, I might as well give it away. I've been brainwashing you. This is the way to solve a problem, and it works. And quiz treat, you showed me it works. Test 1, well, that's another story, but I think everybody learned from their lesson there. Now, what are we being asked to find in number 8? How many moles of sodium chloride? What are we given? A volume, 125 milliliters. And we're given this 3.45 capital NaCl solution. And what does that mean? Capital M, molarity, moles of solute per 1,000 milliliters. And therefore is 3.45 moles of sodium chloride per 1,000 milliliters. Now, the 1.125 milliliters is really the only number we have to start with, and we're trying to get 2 moles of sodium chloride. And therefore, I just remembered I haven't done this. It's time to use your good buddy, your good friend, unit analysis. Love that siren whistle. And whatever you're trying to get to goes on top of the ratio, moles of sodium chloride. Whatever we're trying to get rid of, milliliters, that goes below. And where do we get this numbers in a ratio? From this, the molarity, 3.5 moles of sodium chloride per 1,000 milliliters. Now, I didn't write down, but 125 and 3.45 are 3 significant figures. The 1,000 is an exact number. Therefore, when we do the math, and notice milliliters divided by milliliters cancel out, we're left with moles of sodium chloride, 3 exact number. My answer should have 3 significant figures, because when you multiply and divide, you get the same number of significant figures in your answer as the number you're multiplying and dividing by that has the fewest significant figures. In this case, they're both 3. And 9 is the same thing. 10 is the same thing. And now let's look at 11. You know something? Now would be a good time. Let's take a 5-minute break instead of me rushing through this, and we'll come back and continue. Let's take a 5-minute break. I'll be back. Hopefully you will. And I'll see you in 5. I can get up and stretch. I'm back. All right. Just a quick reminder, don't forget, there's no class, there's no lab tomorrow. We'll do the lab on Wednesday. And more importantly, don't forget, if you have not voted yet, vote today or tomorrow. And if you haven't registered, I think most places in Northern Illinois, counties you live in or I live in, you can register same day, but check to make sure. Oh, I'm shedding. Anyways, make the check that you can do that. All right, let's get back to not important information, but with chapter on solutions, quiz number 4, problems. All right, let's look at number 11. And if this were on something you see in the future from me, it would say this, 10 points. How many G as grams of sodium chloride are needed to make 345 milliliters of a 6.789 capital M NaCl sodium chloride solution? So what are we being asked to find? Grams of sodium chloride. What are we given? The milliliters. And we're also given this number, 6.789 capital M NaCl. As soon as you see a capital M between a number and a formula, that means molarity. Molarity, moles of solute per 1,000 milliliters of solution. So immediately I can write, this means this, 6.789 moles of sodium chloride per 1,000 milliliters. And there's no way I can, which means there's no way you can, so don't try it. I've seen students do that, and it's always 0 wrong. There's no way in one step you can go from milliliters to grams in this problem. You need 2 steps. And important information, as you saw, quiz number 4, the first step is milliliters to moles. What does that mean? Well, we're given 345 milliliters. We're trying to get the sodium chloride, so I guess the moles here mean moles sodium chloride. And how do we get from milliliters to moles of sodium chloride? Use your good buddy, your good friend, unit analysis. Whatever you're trying to get to goes on top of this ratio, moles sodium chloride. Whatever you're trying to get rid of, milliliters, goes underneath. And where do we get these numbers? From the molarity here. 6.789 moles of sodium chloride per 1,000 milliliters. Now, I don't have on here, and I can't write because this is this? No, I can't. I take it back. This is 3 significant figures, 4 significant figures, exact number. And the final number, when you have multiplication division, you should have the same number of significant figures in your answer as the number that has the lowest. In this case, 3 significant figures. So this step, we now have 2.34 moles of sodium chloride. We want to get to grams of sodium chloride. And what do? Step 2, moles to grams. And here we have moles of sodium chloride. Notice our final answer, we want grams of sodium chloride. And whatever we're trying to get to, when you're using your good buddy, your good friend, unit analysis goes on top of the ratio. Whatever we're trying to get rid of goes underneath. Where do we get these numbers? 1 mole of compound equals the molecular weight of that compound in grams. And earlier you saw me point that out. Important information, quiz 4. And therefore, we need the molecular weight of sodium chloride. And important information, quiz 4, it will say 1 mole of a compound equals the molecular weight of that compound. And the molecular weight of that compound is the sum of all atomic weights. And if you look over on the left here, the molecular weight of sodium chloride, there's 1 sodium. And on quiz 4, like quiz 3, it will say, please use all atomic weights to 3. I can do that both hands, I'm ambidextrous. 3 significant figures. And sodium is 23.0. Chlorine to 3 significant figures is 35.5. You add it up, get 58.5. Remember, you get the same number of significant figures to the right of the decimal as the number with the fewest significant figures to the right of the decimal. I like my special effects. But anyways, this has 1, this has 1. That's why the answer has 1. So for every 1 mole of sodium chloride, there's 58.5 grams. And now I haven't done this here, but moles divided by moles cancel out, and you're left with grams of sodium chloride. This is 3 significant figures, 3 significant figures, exact number. And therefore, when I do the math, I get 137, 3 significant figures. You could have also written it like this. And notice I have here both ways. What that means is when you have multiple step calculations, there's 2 philosophies. One is round off at each step or calculation. I'm a round off at each step person, or round off at the very end. And since I'm not going to force you to my way, I have calculated it both ways, and it turns out they're the same number. All right, let's do one more. This is important. We look at 12. How many grams of H2SO4? That's called sulfuric acid. That's probably the most the chemical that the most is made of in the United States, if not the world. H2SO4 is used in many, many things in our daily life and also in the chemical industry to make other things. So now, how many grams of H2SO4 sulfuric acid are needed to make 345.5 milliliters of a 6.77 times 10 to the minus 2 capital M H2SO4 solution? And as I've taught you this semester, when we have, don't get scared, a word problem, these are word problems, find out what are you being asked to find in the units. And here I show that by question mark, grams H2SO4. What are you given? 345.5 milliliters, and this number 6.77 times 10 to the minus 2 capital M H2SO4. And what is it? That capital M? That should ring a bell. Ding, ding, ding. Oh, sorry. But anyways, molarity, capital M, tells you moles of solute per 1,000 milliliters. Therefore, what does this mean? 6.77 times 10 to the minus 2 moles of sulfuric acid, H2SO4, per 1,000 milliliters. Now, if we look up here, we're starting with milliliters. There's no way you can or I can go from directly in one step milliliters to grams of sulfuric acid, H2SO4. And you need 2 steps. And the first step, and you'll be given this important information, quiz 4. Don't forget that's Wednesday and deadline is Thursday, 11 a.m. But here, you go from milliliters to moles, the first step. Here to milliliters, we're trying to get the moles of sulfuric acid. Use your good buddy, your good friend, unit analysis. Whatever you're trying to get to goes on top of a ratio. Whatever units you're trying to get rid of go underneath. And where do you get these numbers? From knowing this, the molarity means this. And therefore, there's 6.77 times 10 to the minus 2 moles of sulfuric acid per 1,000 milliliters. Now, this is 4 significant figures. The 1,000 is an exact number, and this is 3 significant figures. So when you're multiplying and dividing, the number you get should have the same number of significant figures as the number you're multiplying and dividing that has the lowest significant figures, which means your answer in step 1 should have 3 significant figures, and it does. Now, in step 2, you go from moles, or whatever you just calculated, to grams of your answer. And here that's H2SO4. So we just calculated moles of sulfuric acid, 2.34 times 10 to the minus 2 moles. We want to get to grams of sulfuric acid, and you use your good buddy, your good friend, unit analysis, and whatever you are trying to get to, the units go on top of that ratio. Whatever you're trying to get rid of, the units go underneath. And where do I get a relationship between moles of a compound and grams of a compound? 1 mole, and this is an important information, quiz number 4, 1 mole of a compound equals the molecular weight of that compound, and the molecular weight of that compound is the sum of all atomic weights. And remember, use all atomic weights to 3 significant figures. And therefore, for H2SO4, 2 hydrogens, 1 sulfur, 4 oxygen. The atomic weight of hydrogen to 3 significant figures is 1.01. The atomic weight of sulfur, remember you get that on the periodic table underneath the chemical symbol, the one you get from me that you can download, that will be 32.0 for sulfur to 3 significant figures, and for oxygen, that's 16.0. Do the math, 2 times this is this, 1 times this is this, 4 times this is this. You add it up. Remember, you get the same number of significant figures to the right of the decimal as the number that has the fewest significant figures to the right. And if you look here, this is 2, 1, 1, and this I round off 98.02. Keep the 0, round the 2 off, that's 4 or less, drop it. And the molecular weight of sulfuric acid is 98.0. And now, if we look at this, 3 significant figures, exact number, 3 significant figures. The final answer should have the same number of significant figures as the number that you're multiplying, dividing, that has the fewest significant figures. And remember, exact numbers are not involved in this. And therefore, 3, my answer is 3, 2.99 grams of H2SO4. Now, notice I have both ways. Again, I'm a round off at each step person. And if you're a round off at the end, I accept either answer. In this case, they're the same. And with that, we're done with quiz number 4, actually the solutions problem set. Any questions on that? All right, remember, no class tomorrow because it's election day in Illinois, which is a holiday. state holiday. Wonder if the banks are going to be open. Probably are, because they're on a federal, not a state holiday schedule. But I'll call because I got to get to my bank this week. Stuff I need to put in my safety deposit box. But anyways, that means let's go into guess what? I don't have it opened up. Let me close a couple of things. All right, everybody see chapter 15 on your screen, chemical equilibrium? Thank you, thumbs up, people. Oh, my 2 G's came through. All right, remember, this will not be on everybody else who came through. Thank you. This will not be on quiz 4. It will be on quiz 5, which is a couple weeks away. The end of the semester isn't that far away. Thanksgiving isn't that far away. Why, where does semester go? I guess time flies when you're having fun with chemistry and Dr. White. All right, let's get back to where we were. I talked last week about exothermic and endothermic reactions, and I talked about the energy diagram for these, and I did that. So let's move on. Now, there's a very important concept in chemistry called chemical equilibrium. And what chemical equilibrium involves are reversible reactions. And that consists of a reaction that can have both a forward and reverse reaction happening at the same time. Let's just say if I had A plus B reacting to make C plus D, that would be a reaction. Now, you could also have a reaction if I mix C and D together, it will make A and B. And notice both of these are opposite reactions of the other. In the first one, A and B makes C and D. And the second one, C and D make A and B. And the way we show this reversible reaction is like this. And you see the double arrows indicate a reversible reaction. And what this tells us right here, A and B make C and D, plus C and D make A and B. And that's a reversible reaction. Everybody clear on that? Oh, one thing, because I'm an organic chemist. Thank you, Gianna. Sometimes, like a lot of times, I'll do it this way. And this is 2 different ways of drawing the arrows. I shouldn't have drawn more arrows. You're going to be overdosed by arrows. But anyways, let's call this A and B. It's the same way, just how you write your arrows. Those are 2 different styles. Now, when you have a reversible reaction, something very interesting can occur, and that's called chemical equilibrium. Again, remember, this is quiz 5 material. And can't know this. And what's a chemical equilibrium? That's the state in which forward and reverse reactions occur simultaneously at the same rate. i.e. means that is the rate of a reaction are equal. Another way of saying that is the process which two opposing chemical reactions occur simultaneously at the same rate. So if we have a chemical equilibrium, because this is a chemical equilibrium, if this is a chemical equilibrium, what we know are for a chemical equilibrium, the forward and reverse reaction rates, how quickly things are consumed, how quickly things are made, are the same. So when you have two reactions, one is the reverse of the other in a chemical equilibrium, A and B making C and D, and C and D making A and B, the forward and the reverse reaction rates are the same. Hint, know this. Now, one of the things, and I always forget which, chemical equilibrium plays an important part in our life. And I think your lungs, but don't quote me on this, and either your kidneys or your liver, maybe both, all operate as chemical equilibrium, which keeps us alive. So why are you learning this stuff? Well, it's happening in your body. Hope I didn't scare anybody. Now, when we talk about equilibrium, chemical equilibrium, there's an important concept, and that's called the equilibrium constant. And the equilibrium constant, and I'll never ask on a test, what's an equilibrium constant, is a numerical value that characterizes the relationship between concentrations of reactants and products in a system at chemical equilibrium. Wow, that was a lot of, I better take a drink after saying all that. So once again, and I'll never ask on a test, an important concept in chemical equilibrium is the equilibrium constant. And that's the numerical value that characterizes the relationship between concentrations, molarity of reactants and products in a system that's at chemical equilibrium. And when you're at chemical equilibrium, the forward and reverse rates, reaction rates are the same. Now, let's look at the following reaction. Can everybody see this right here? WA plus XB. Thank you, Gianna Williams. Oh, it even says it on the slide here. Know this. All right. Now, what does that mean? WA plus XB. Remember, W and X are coefficients. A and B are chemical formulas. So that tells me W moles of A react with X moles of B to make Y moles of C plus Z moles of D. And by definition, chemical equilibrium, which is abbreviated by capital K, EQ, K in chemistry means constant, and EQ is for equilibrium, is the concentration of each product to the power of the coefficient divided by the concentration of each reactant to the coefficient of the reactant. And here, K to EQ, the equilibrium constant, and in brackets, notice right here, when you have a formula inside a bracket, that's moles per liter, molarity. So for that reaction, the equilibrium constant is moles of C to the Y power times moles of D to the Y C power divided by moles of A to the W power times moles of molarity of B is not moles, molarity of B to the X power. Let me say that again, because I made a mistake. Molarity of C to the Y power, molarity times molarity of D, the products which are on this side, and underneath you have the reactants, molarity of A to the W power times molarity of B to the X. And this is the equilibrium constant. And either today or tomorrow, not tomorrow because there's no class, Wednesday, I'll have time to talk about the significance of K equilibrium. And either this week or next week, I'll explain next week probably, maybe not, maybe Wednesday, I'll talk about how you use these concepts in the chemical industry. Don't forget, I worked many decades in the chemical industry. All right, similar reaction. I don't know if I use the same letters, but the equilibrium constant is the concentration of each product on the right, C, to the coefficient power times the concentration of D to the power of the coefficient X divided by the concentration of each reaction. We put it in brackets. That means concentration, moles per liter, of W to that power, the coefficient, times moles of the other, molarity of the other. I said moles, it should be molarity of the other reactant to that coefficient power. So let's look at the following. And if you look at the following, the question is 6 points. What is the equilibrium constant, KEQ, for the following? And sometimes I might even write out equilibrium constant. Well, you're given this reaction. So K equilibrium, I want to write out EQ, but you people don't know cursive. But anyways, is the concentration of the products. In this case, it's sodium chloride to the power of the coefficient. And then on the bottom, you have the concentration of each reactant to the power of the coefficient. Number in front of sodium is 2, and I'm going to rewrite this. And chlorine, when there's no number, that's the number 1. And let me write this in larger script. And that would be the equilibrium constant, the formula. Now, can you keep a secret? Little gift from Dr. White. A lot of times you'll see instructors put a problem. This equilibrium, there's so many moles per liter of this and that and that and that. What's the numerical value of the equilibrium constant? Guess what? I've never had to do that in my life. As a chemist, you look them up, but you know how to figure them out, and I'll show you why in a second. And therefore, on my test, I'll ask this kind of question, 6 points, what is the equilibrium constant? And here's how you figure it out. But I will never ask, giving you certain values for sodium chlorine concentration and sodium chloride, what's the actual number? That's my gift to you. Thank you, Dr. White. You're welcome. Time out while I look up something. I'm looking in a book for some examples. All right. Now I'll do this one. Then I did something I shouldn't have. Hang in there. This way I can come back and get some more examples. All right, let's take a look at this B. And here we have an equilibrium, which means the forward and reverse rates, that's shown by the double-headed arrow here, arrow on top, arrow on the bottom. And the question is, what is the equilibrium constant for this reaction? Now, the equilibrium constant is the molarity of each reactant or each product on the top to the power of the coefficient of that product divided by the molarity, the concentration of each reactant to the coefficient power of that reactant. And therefore, K equilibrium for this, notice on this side is the products. Here are my reactants. And therefore, the first thing, carbon disulfide, stinky stuff, that's, remember, when there's no number, the coefficient is 1, is times, and then the next one, hydrogen, and the coefficient is 4, so you make it to the power of 4. Underneath, the first reaction, CH4, called methane, the coefficient, when it's 1, well, you don't have to put anything there, times the concentration of hydrogen sulfide, which is also stinky, and the coefficient is 2. Let me rewrite this again. All right, and that's how you do it. Now, watch closely. A common mistake that students make, and see, it even says wrong on there, they'll write down this. Instead of a multiplying, they'll put a plus. And this is wrong. And you'll get 0 points. Wrong. So remember, it's a multiplication, not an addition. I don't know why students do that, but over the years, you see it a lot. I see it a lot when I'm grading. So I'm telling you, don't do it. It's wrong. And since Dr. White likes to share the fun, let's have one for you to try. Uh-oh. Oh, I know why. The book was pushing down on my control key. I didn't notice that. All right. And when you're doing equilibrium constant, it's always for a balanced chemical equation. And on test or quiz, I will always give you a balanced chemical equation. So write the equilibrium constant for and it's your turn. Now, I'll write down here, and this I think I'll have to look. Hold on, I think there's a way I can do this. Let me try great moments. Nope, that didn't work. All right, remember, for the equilibrium constant, it's the concentration of each product to the power of the coefficient of each product, you multiply, divided by the concentration of each reactant to the power of that reactant. And here, for some reason, C got moved over. All right, your turn to do this. And give me a thumbs up when you're done. Again, is the concentration of the products to the power of the coefficient of those products divided by the concentration of each reactant divided by to the power of the coefficient of that reactant. Coefficient is the number in front of the structure in a balanced chemical equation. And don't forget, if you haven't, I hope you have by now, for quiz 4, do the practice problems for the solution practice problems. I think that's chapters 12 and 13, but I'd have to look. I'm part of 13. Yeah, I just remembered something I didn't talk about in the review. So since we do this one, I'll talk about that. When you're done, give me a thumbs up. Or if you want me to do this problem, give me a thumbs up. All right. K equilibrium. Here are the products. Here are the reactants. And it's a ratio, the concentration of each product to the power of the coefficient times each one. And notice the second one is chlorine. You put it in a bracket, the coefficient is 2, divided by the concentration of the reactants. Notice the coefficient for HCl is 4 times oxygen. When there's no coefficient, that's 1. And that's how you do it. All right, time out for, I just remembered, I forgot. All right, important thing about solutions that you should know for quiz 4. Hold on. Ooh, my finger was, it's broken again. But for quiz 4, and that is boiling. Boiling is when the solution you're heating, like water, you see those bubbles in there, they come to the top. In the bubble is water in the gas state. We call that water vapor, collapses. That gives off water vapor. It's a gas. When the pressure of the water vapor equals the atmospheric pressure, that temperature is the boiling point of water. Now, as we go higher altitude on our planet, the pressure, atmospheric pressure, is less. Therefore, you need less energy to make equal amount of vapor pressure. And that means, and this is important, hint, the higher you go on our planet, altitude-wise, the lower the boiling point because of the lower atmospheric pressure. And as I remember I talked about in lecture, if you go to Denver, the boiling point is lower than the boiling point of water in Chicago, because Denver is higher. That's why it's called the Mile High City. And if you go to the top of the Himalayas, Mount Everest, or if you go to Kathmandu, there's a famous song by, who did that when I was in college? I can't remember his name. But anyways, I can't think of his name now, famous singer. It's going to bother me all morning. But anyways, when you go to the top of the Himalayas, what happens to the boiling point? It goes way down. Why? Because the atmospheric pressure at the top of the Himalayas, like Mount Everest, is way down. If you go back and look in my video when I talked about that, I think, let's go look. I'm not going to cheat you. Don't forget, look up Monty Python for your own edification and fun. And notice at sea level, Chicago, water boils at 100 degrees C. Because of the lower atmospheric pressure on the top of the Mount Everest, top of the Himalayas, water boils at a whopping only 68 degrees C. And that's because of the lower atmospheric pressure. I'm glad I remembered that one. All right, let's do another one of these. And let me rewrite this. And why don't you try for this one? What's the equilibrium constant for that equilibrium? And I don't know if I put this in important information, quiz 5. I haven't written it yet, but This is something you should know. Your turn. And give me a thumbs up when you're done. When you're done, give me a thumbs up. Or if you want me to go ahead and do it, give me a thumbs up. Well, I see one person done. I see two. I see everybody's done, so it's my turn. Now, remember, this is determined by products concentration to the power of the coefficient divided by reactant. Concentration to the power of the coefficient. This is my only reactant. These are my products. Therefore, K equilibrium equals the concentration of nitrogen. That's why we put these brackets times, not plus, the concentration of the other product divided by the concentration of the reactant. And notice here the coefficient is 2. And that's how you do it. If I look at the clock, oh no, I'm out of time. All right, don't forget, Wednesday after class, I will send out an email with the password. You'll have until Thursday, 11 a.m. to upload your answers to quiz 4. Quiz 4 is on solutions. Don't forget, tomorrow there'll be no lecture, no lab. The lab will do on Wednesday. Why? Tomorrow's election day in Illinois. That's a state holiday. COD is closed, which means I also won't have my office hour tomorrow. But hopefully you can go back and look at the videos like today's. And with that, I'll say, don't forget to vote. This is probably one of the most important elections in my lifetime and maybe yours. And with that, I'll say, Gang gesund, goodbye. Remember, Gang gesund means going out. And this I stole from Granny of the Beverly Hillbillies. Gang gesund, goodbye. I'll see you on Wednesday.